Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam IFM, Investments in Financial Markets. You are to price options on the futures contract. The movements of the futures price are modeled by a binomial tree. You are given that each period is 6 months. U over D is 4/3, where U is 1 plus the rate of gain on the futures price if it goes up, and D is the 1 plus the rate of loss if it goes down. The risk-neutral probability of an up move is 1/3. The initial futures price is 80. The continuously compounded risk-free interest rate is 5%. Let CI be the price of 1-year 85 strike European call option on the futures contract, and C2 be the price of an otherwise identical American call option. Determine C2 minus C1. So the risk-neutral probability of an up move is P star equal to 1 minus D over U minus D. You need to remember this formula that applies to futures. That's the same as 1 over D minus 1 over U over D minus 1. And we know this probability to be 1/3, and we also know that U over D is 4/3. And we plug that in, we get the equation, solve it for D, and D is 9 over 10, or 0.9, and this implies that U is 4/3 D, and that's 4/3 times 9 over 10, or 1.2. And then we have the two-period binomial tree that looks like this, that shows us the prices starting from 80 in an up move to 96, down move to 72, up move to 115.2, down move to 86.4, or down up leading to the same result, and then down to 64.8. And then what you see in parentheses is the payoff of the option at the end of the contract, but here we have the payoffs based, actually the present value, expected present value in parentheses of these two payoffs based on the probabilities and the expected present value at that time versus the early exercise value, which is 11 in this case, and there is no early exercise value in the down node at 72. And of course, for the American option, you'll have to compare the expected present value of the future payoffs of 10.72841 with the payoff in case of early exercise, which is 11. And therefore, the American option would be exercised early at this node. And otherwise, there's no difference between the two options, so we only need to compare how those two options relate to each other based on the two alternative payoffs at this node. So as I mentioned, bold italics of 11 indicate early exercise, and the calculations of the European option prices at time 0.5 based on the expected present value of future payoffs is given here. That's what you see in parentheses there. And the difference of the two is the expected present value at time 0 of the difference of the two payoffs, early exercise of 11 versus the actual present value of future payoffs of expected present value of future payoffs of 10.72841, and we calculate the value of that difference at time 0, and this comes out to be 0.088. And of course, this is the present value factor, e to the it should be minus 0.05, so let me correct that. Minus 0.05 times 5, the difference of the payoffs, times 1/3 the probability of an up move. And that's answer E. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on your test.